We got our last set of examples here, starting at number 11. What is the arc measure of AC? So the measure is talking about the number of degrees, and so we can look at the central angle to get that. We have a 90 degree and a 25 degree, so 90 plus 25 is going to equal 115 degrees. Number 12, what is the arc measure of AE? So A to E here, we see that we have a straight line here. We have 90 degrees used up and 25 degrees used up, leaving us with only 65 degrees left to get to 180. So if you're trying to figure out 180 minus 90 is 90, minus 25 is 65. And that's going to correspond to the arc length, the arc measure. Not the arc length, just the arc measure. 65 degrees. What is the arc measure of AEC? Clean up our picture here. So AEC. We said this was 65, and we know that this whole thing together over here is 180 if you go this entire piece, because that's a straight line. So if we add up those pieces, 65 plus our half circle, 180, we're going to get 245 degrees. Next part, it says find the arc length of WZ. Now this time it is different than the arc measure. The length is a distance, the measure is just an angle. So we want to know how long WZ is. To clarify on our picture here, let's clean this up. This 46 is referring to degrees, so put a degree symbol. And then the 30 is referring to a diameter. It is the distance from here all the way down to there. So 46 degrees, distance of 30. Our circumference is the whole distance around. So circumference is equal to pi times the diameter, or in this case, pi times 30. The arc length is what fraction we have of that 30 pi. So we have only 46 degrees out of 360 degrees in a circle. That's all we've got for the central angle, is 46 degrees of the 360. And we multiply that fraction by our 30 pi. If you take these numbers now and plug it into a calculator, I would potentially leave off the pi right away. So do 46 times 30 divided by 360, hit enter, get your number, and then multiply that value by 3.14. And that will give you a rounded answer. Since your fraction is going to come out kind of nasty anyways, you might as well just stick with the rounded theme and multiply by 3.14. I'll accept decimals rounded to the nearest tenth. So if you go ahead and plug this in, let's see what we get. Comes out to approximately 12.03. 12.036, so 12.04. Now, with these, again, rounding would be acceptable. If you want to do a quick common sense check to make sure that makes some sense, if your diameter is 30, your radius is 15, you can see that this looks to be a little bit less than a radius length, so a little bit less than 15, so that seems to make sense. Go down to 15, it says find the radius if the arc length is 58.25. And it looks like our degree measure is 320. So we can set this up by saying our arc is equal to our circumference, and we can write that as just C, times 320 over 360. And since we know our arc length, we can actually replace that as well with 58.25. So 58.25 equals C times 320 over 360. If we want to get C alone, we need to multiply both sides of this problem by the flip by the reciprocal of the fraction. So let's multiply that in a different color here. We need to multiply both sides by the flip. 360 over 320. Same over here, 360 over 320. These cancel, leaving just c alone on one side. And then on this side here, we're going to have to plug it in. So 360. So 360 divided by 320. And then we take that number and we multiply that by 58.25. And we get 65.53. Now, why is that useful? Because we want the radius. Well, conveniently we have a way to get the radius once we know the circumference. We know that the circumference is 2 times the radius times pi. So if we know that and we want to get radius by itself, we would take the circumference divided by 2 divided by pi. And that would leave us the radius alone. So if we divide by 2 pi on both sides, the radius is alone here. So let's go ahead and divide this by 2 pi. So divided by 2, and then divided by 3.14. And we get 10.43. So our radius here is 10.43. To have a radius of about 10, and then to have the distance around most of the circle be about 58, that seems to make pretty good sense. So I think that this is a pretty logical answer that we got here. Finally, we got one more problem here. We're asked to find the arc length once again. We know our radius, and our radius here is 6, which means our distance around the whole circle is 2 times the radius times pi. And in our case, our radius is 6, so 2 times 6 times pi. Distance around the whole circle is 12 pi. We have only 120 out of 360 degrees. So we only have 120 here of the 360. So we take 120 of the 360 times 12 pi. Now, if we reduce this fraction, it does look like it's going to reduce nicely. 12 and 36. There's 3 12s in the 36. So that reduces the 1 on top, 3 on bottom. And we know that 12 divided by 3 is 4. So we can take a 4 here and reduce this all the way down to 1. And since we only have 1s here, this is all going to go away because we're multiplying, leaving us with just 4 pi remaining. So the arc length here is 4 pi. Again, I would accept rounded answers, but when things work out very nicely like this, it's a lot easier to just keep it exact in terms of pi. When things like the last two problems, where you have a lot of nasty decimals, then it's probably a better idea to just round it.